All right, today what we're doing is we're going to do day 2 of 11.3, which is probability of multiple events happening. Okay, so what I want to do is first, let's define what a prime number is. I want you to write this at the top. A prime number is a number that's divisible by 1 itself. The first prime number is 2, it's now 1.
Teachers and students, please excuse the interruption. Attention boys and girls track. Today's meet is canceled. Practice tomorrow. JV athletes turn in their uniforms tomorrow. Thank you.
Okay, I'm listing only the prime numbers up to 20. From 1 to 20, those are the prime numbers. Now, we're going to draw a Venn diagram. I want you in this first circle right here, I want you to list all of the numbers that are numbers greater than 12. So what are all the numbers greater than 12? Okay, and in this circle, you're going to write all the prime numbers between 1 and 20. And so in this middle part will be the numbers that are greater than 12 and prime. So let's start with that. Let's start with the middle. Which numbers are bigger than 12 and prime? What numbers would go in this middle region?
13, 17, 19.
13, let's put them down. 13, 17, and 19. Okay? So now, can you give me the numbers that are, the other numbers that are greater than 12, what would go in here? We have 14, we have 15, 16, 18, and 20. Now, why am I not writing 13, 17, and 19? Because they're in this circle. Does everyone understand that? Now, list all the prime numbers between 1 and 20. Now, I'm looking at this circle. I'm not going to put 13, 17, and 19, but I do want to write 2, 3, 5, 7, and 11. So now, can you tell me what is our sample space? These are all the numbers. Don't look at this. This is just I just wanted to write what we're putting in each circle. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 total numbers. Okay, that's going to be our denominator. So can you tell me, if you selected a number at random in this, what would be the probability that the number is greater than 12? How many are greater than 12? Can you count for me? 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 13 are greater than 12. Can you tell me how many are prime? 8 out of 13. How many are greater than 12 and prime? These ones right here. Three out of 13. And now this last one. How many are greater than 12 or prime? How many are greater than 12 or prime? Well, there's 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 out of 13. Now, how can you get this? This is called an inclusive event. It's inclusive because you can have numbers that are greater than 12 and prime. So if you can have this happen, both items happening, it's called inclusive. In inclusive, this is what you do. So if I want to know what's the probability of a number greater than 12 or prime, it's an inclusive probability, and this is the formula you do. You do the probability of the first, so in other words, the probability that the number is greater than 12, so probability, I'm going to write greater than 12, plus the probability that it's prime, prime, and then you subtract the probability of greater than 12 and prime. So it looks like this. You would do the probability of it greater than 12 plus the probability of prime, and you minus the probability of those that are greater than 12 and prime. Now watch this. Let's do this, see if we can get it. So how many are greater than 12? 8/13. How many are prime? 8/13. And how many are greater than and prime? 3/13. What is 8 and 8? 16. What's 16 minus 3? 13. So guess what? That's how we got that mathematically. Okay? Mutually exclusive, we talked about this yesterday. That's when two or more events cannot happen at the same time. So for example, if I say, what's the probability of rolling a 1 and a 2 on a die, a single die? That's mutually exclusive. You cannot roll a 1 and a 2. Okay? So if I said, what's the probability of rolling a 1 and a 2 on one die, one single try? It is 0. You cannot get a 1 and a 2 at the same time. We say when two events cannot happen at the same time, they are mutually exclusive. If the two events cannot happen at the same time, what we'll do is change this to an or, and we'll say 1 or 2. If they are mutually exclusive and cannot happen at the same time, what you're going to do is you are going to add up the two individual probabilities. So on the back side is the equations. So if it's a probability that would be exclusive, meaning if I asked you to roll a 1 and a 2, you can't do it at the same time. So they're going to turn it into an or problem. They're going to say probability of A or B. And what you do is you add them up. That's if these two events cannot happen at the same time. Now, if it's inclusive, inclusive means it's not mutually exclusive, meaning it can happen. And that's what we do on that one problem I did right here. If it can, if there's some numbers that are both, what you do is you find the probability of each one separately, add them up, and then you take the probability of both of them together. So if it can happen, you do the inclusive formula. If it can't happen at the same time, they'll turn it into an or problem, and then what you do is just add them up. Okay? So, first thing, you need to know when something's mutually exclusive and when it's inclusive, because it's going to depend on the formula you use. So, again, mutually exclusive, two events cannot happen at the same time. Inclusive, it can. There's some areas where you can. So let's talk about these. Can you, let's talk about whether they're inclusive or not. Can you have black hair and can you wear glasses?
Yes.
Yeah. I have black hair and I wear glasses. So that's inclusive. Okay? Now, the next one. Let's pretend like you can only have one color eyes, because first and fourth hour wanted to call that one inclusive. But let's just assume you can only have one color eyes. What would you say on this one? Mutually exclusive. Okay, I understand some people have blue and brown eyes, but if you were filling out a form and it said color eyes, it's going to say brown, blue, green. You circle one.
What would they put if you did have?
I don't know. I don't know. I don't know. It's like saying, can you be 5 feet tall and 6 feet tall? No. I mean, you could say, oh, well, if you put shoes on, high heels, or, you know. Yeah, I guess then there's some cases, but we're talking, let's just think about a normal person has one color eyes. Yeah, there's some exceptions. So I guess this is a gray area on that one. So now I know, based on our discussion in first and fourth hour, I won't put that one on a test. What about this next one? Can you be a number bigger than 12 and can you be a prime number?
Yeah.
There is no gray area on that one. That's inclusive. Can someone give me an example of a number that's bigger than 12 and prime?
13.
13, there you go. So it can. These are the cans, and these are the can'ts. Can'ts happen at the same time, cans happen at the same time. How about the last one? Can you find me a number that's a multiple of 4? So multiple of 4 is 4, 8, 12, 16, 20. And it be odd? No, I can't. I can't think of anything. Okay? So, step 1 is you have to determine if it's mutually exclusive or if it's so can you have some of those numbers that are both? If it's mutually exclusive, all you do is add the 2 up. If it's not mutually exclusive, it's inclusive. Not mutually exclusive. Is this one right here. So now let's talk about these ones, and if we're going to use each formula, whether it's mutually exclusive or inclusive. So number 1, if I asked you to roll 1 die, could you get a 1 and a 6? Could you get a 1 and a 6? No. So to get both of these numbers at the same time, it's mutually exclusive. But if I say get a 1, if I change the word from and to or, now what you're saying is just add the 2 separate. So what's the probability of getting a 1 plus the probability of getting a 6? How many 1s are there on a die?
1.
And how many 6s are there? So what's 1 6 plus 1 6? 2 6, or you have a 1 out of 3 chance. Okay, next one. Now think about this question. Is it possible to get, now what are the numbers on a die? 1, 2, 3, 4, 5, 6. Can you get an even and a prime number at the same time? Yes, you can. I'm pointing to it right now. The number 2 is even and prime. So this one's not mutually exclusive. Believe it or not, it's inclusive. You just gotta think. So if it's inclusive, this is the formula you're gonna use. You're gonna do the probability of it being even plus the probability of it being prime minus the probability of even and prime. And that's the answer. So, how many even numbers are there on a die? 3. So 3 out of 6. How many are prime? 1 is not prime. So 2, 3, and 5. And how many are even and prime? 1. So what's the probability of rolling the die and getting an even or a prime?
5, 6.
5, 6. Good job. Try the next one. Okay, let's write all the numbers of a die. Can you get a number that's a multiple of 2 and 3?
Yes.
Yes, 6 is a multiple of both of them. So this one's inclusive. So you're going to do the probability of a multiple of 2 plus the probability of a multiple of 3 minus the probability of a multiple of 2 and 3. So what's the probability of the number being a multiple of 2? Which ones are multiples of 2? 3 of them. So 3 out of 6. So this is 3, 6. How many are multiples of 3?
2.
How many?
2.
2. And how many are multiples of 2 and 3?
1.
And what's 3 plus 2 is 5. 5 minus 1 is 4. 4, 6 is equal to 2/3. Anybody got any questions? Okay, now, I understand you guys aren't, we have a deck of cards. A lot of you guys don't know much about the cards here. Face cards, you know, you have king, queen, jack. These are called face cards. There's 52 cards in a deck, right? Does everyone know that? You've got ace, king, queen, jack, 10, 9, 8, 7, 6, 5, Okay, so Jack, King, Queen, Jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. Ace is considered a number card. We researched this in fourth hour. Okay, we Googled it. Ace, you're gonna consider ace a number card. And the reason why I thought ace was a face card, so I was wrong. Face cards, I guess, are the cards that have faces on them. And these are the three, and so there's actually 3, 6, 9, 12 face cards. So there's 12 face cards. And we're gonna go with 40 number cards. Okay, so I have some questions for you. Can you pull a heart and an ace at the same time? A heart? Yeah,
Yeah.
you can.
Yep.
Yeah, you can. So you can. It's inclusive. So how will you do heart or ace? So I need the probability of a heart plus the probability of an ace minus the probability of the ace of heart. Does that make sense? So how many hearts are there? How many hearts are there?
10. Wait, including the face cards?
13.
14.
There's 13. There's 13.
Oh,
1,
Yep, 13.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is going to be 13 out of 52. How many are aces?
4.
4. And how many are ace of hearts?
1.
Only 1. What do you get here? 16 out of 52, and make sure you reduce it to 4/13. For B, can you have a face card and a number card? No.
But it says or.
I know, I'm asking you if this said and, can these two come up to be at the same time? If you drew one card from the deck, could you get both of these at the same time? No. So we turn it into an or. So it's mutually exclusive if you were asked, can you do this at the same time? No, you're gonna get a face card or a number card, it's one or the other. So now watch this. How many face cards are there?
12.
12. How many number cards did we say there were?
40.
40. See if this makes sense. So, if I gave you a deck of cards and said pick a card, is the probability that you get a face or a number card 100%? Yeah. Whatever you get, it's either gonna be a face card, if we call the number cards 40. That's what Google said. I mean, I did not think ace is a number card, but they called it a number card. So that was, I thought just these would be number cards.
Well, the ace is counted as one.
They counted as one, why don't they, so this is what fourth hour said, why don't they call it one?
It's to do with a lot of games that they play.
But why don't they put a 1 on it?
Isn't there only one thing on it?
But it's either
Usually
one,
just one.
But there's not the number
right,
1.
it's either a 1 or 11. If you play-
It's
card
an
games.
ace. So I don't know. We're just gonna call an ace the number 1, okay? Last one, can you get an odd number and a red number? Yeah, so that's inclusive. So we're gonna do this, probability of an odd plus the probability of red minus the probability of all of the odd and reds. So let's look at this, okay. How many are odd? Are we calling ace odd?
Yep.
Okay, 1, 2, 3, 4, 5. 5 times 4 is? How many are red? There's 13 and 13, these are both red. There's 13 red here and 13 red here, so that's 26. How many are odd and red? So we have 2, 4, 6, 8, 10. So what do you get here? This is 46. 46 minus 10 is,
36 over 52, which reduces to 9 over
9 over what?
13.
Yep. And there it is. Do you understand this, guys? Okay, good. All right, so for homework, you're doing this worksheet right here. You're gonna go all the way up to 29, front and back. Emma, can you turn that off, please?